Hello students, let's continue the chapter alcohols, phenols and ethers. And the topic is preparation of ethers. From preparation of ethers, our second method is Williamson synthesis. Dear students, simple as well as mixed ether can be prepared in laboratory by Williamson synthesis. In this method, alkyl halide is treated with sodium alkoxide or sodium phenoxide to give dialkyl ether or alkyl aryl ether. As you have seen in the example, alkyl halide is treated with sodium alkoxide. Alkyl halide means Rx, sodium alkoxide means RONA. It gives diethyl ether. Same here, when alkyl halide is react with sodium phenoxide, it gives alkyl aryl ether. Means when alkyl halide is treated with aryl halide, so it gives alkyl aryl ether. These two are the general example for Williamson synthesis. Dear students, these reactions follows SN2 mechanism. As you all of you know what is SN2 mechanism. Ether is formed as a result of backside attack by alkoxide of phenoxide ion on alkyl halide. The alkyl halide used in this reaction must be primary. Always remember student, the alkyl halide which is used in this reaction must be primary. Now take an example, methyl iodide when it is react with sodium ethoxide. So the main product is ethyl methyl ether. Sodium react with iodine and it will form sodium iodide, and C2H5O means ethoxide group react with methyl group, it form ethyl methyl ether. So as you have seen student, alkyl halide which is used in this reaction is primary alkyl halide, means methyl iodide is a primary alkyl halide. When we are using secondary or tertiary alkyl halide, elimination reaction is proceed and the product is alkene. Means if secondary or tertiary alkyl halides are used, the reaction leads mainly to alkene formation. Student, please remember these 2 points are very important. If in Williamson synthesis primary alkyl halides are used, the main product is ether. But if secondary or tertiary alkyl halides are used, the reaction leads mainly to alkene formation and elimination reaction is proceeded in this method. Now see the example, tertiary butyl chloride. As you have seen, it is a tertiary group. The carbon atom which is attached with a functional group is connected with a 3 another carbon atom, means it is a tertiary group. It is react with sodium ethoxide. So sodium will react with chlorine and the byproduct is NaCl. Ethyl group is react with one of the hydrogen atom from here and ethyl oxide group react with one of the hydrogen atom from here and it form ethanol. Remaining compound is CH3, C, CH3, double bond CH2. Because one hydrogen atom is removed from here and it will react with C2H5O and form alcohol. Sodium react with chlorine and it forms sodium chloride. And the remaining part is alkene, means CH3, C, CH3, double bond CH2. Student, always remember, aryl halides do not give Williamson synthesis. So, this is the topic for the preparation of ether from Williamson's synthesis. Now, the next topic from this chapter is physical properties of alcohols and phenols. In this, the first property is nature of intermolecular forces. Nature of intermolecular forces. Always remember, student, alcohols and phenols are very polar molecule, means carry positive and negative charge. Due to this polarity, why these are polar molecule? Because of presence of OH group. Students, alcohols and phenols are very polar molecule due to presence of hydroxyl, means OH group. The polar OH groups are held together by the strong intermolecular forces, and these forces are nothing but a hydrogen bonding. Again listen carefully, students. The polar OH group are held together by the strong intermolecular forces, namely hydrogen bonding. As you have seen here, all of you know what is hydrogen bonding. When hydrogen atom attached with a strong electronegative atom, so it's form hydrogen bonding. It is clearly seen in this example that hydrogen atom when attached with the oxygen, as all of you know, oxygen is a strong electronegative atom, so hydrogen atom form intermolecular hydrogen bonding. Same example you can see in phenol also, means in both alcohol and phenols, hydrogen bonding, intermolecular hydrogen bonding is formed, and these two are polar molecule. So this is the nature of intermolecular forces. Next, physical properties of alcohols and phenols is physical state. Lower alcohols are colorless toxic liquid and having characteristic alcoholic odor, and pure phenols are colorless, toxic, low melting point, solid, having characteristic carbolic or phenolic odor. Students, we are studying physical state of alcohols and phenols. So lower alcohols are colorless, toxic liquid having characteristic alcoholic odor. Pure phenols is colorless, toxic, low melting point, solid having characteristic carbolic or phenolic odor. Next physical property is boiling point. The boiling point of alcohols and phenols increases with increase in their molecular masses. Means boiling points of alcohols and phenols are depends on molecular masses. Next physical property is solubility. Phenols and lower alcohols. As student, you are aware about the lower alcohols, means which are having up to 3 carbon atom. So phenols and lower alcohols show appreciable solubility in water. Why? Because due to their ability to form intermolecular hydrogen bonding with water molecule. As we have seen already, intermolecular hydrogen bonding in alcohol and phenol. So phenol and lower alcohol are soluble in water. Why? Because having ability to form intermolecular hydrogen bonding with water molecule. So these are the 4 physical properties of alcohols and phenols. First property is nature of intermolecular forces. Second is physical state. Third is boiling point. And fourth is solubility. The next topic from this chapter is laboratory test of alcohol and phenol. From this test, the first test is litmus paper test. As all of you know what is litmus paper. So students, you are aware that when any compound change the blue litmus to red, so it is acidic in nature, or red to blue, so it is basic in nature. Water soluble alcohols and phenols can be tested with this method. Aqueous solution of alcohol is neutral to litmus, means neither blue nor red litmus changes color. An aqueous solution of phenol turn blue litmus to red. What does it means? Phenol have acidic in nature. Student, this is the old method for testing the alcohol and phenol, and it is used for water soluble alcohols and phenol. What is the result? Aqueous solution of alcohol is neutral because neither blue nor red litmus changes color. An aqueous solution of phenol turns blue litmus red, means it is acidic in nature. Second test is reaction with base. Reaction with base. So acidic strength of phenol being very low, phenol cannot react with sodium bicarbonate, but it is react with sodium hydroxide, means NaOH. See the example. Phenol means ArOH does not react with sodium bicarbonate. No reaction is there. But it can react with base means NaOH, it form ARONA. Sodium phenoxide means OH is react with H, it form water molecule, and ARO group, phenoxide group, react with sodium, it forms sodium phenoxide. This sodium phenoxide react with HCl. So sodium will react with Cl, it forms sodium chloride, and ARO group react with hydrogen, so it form AROH phenol again. So students, because of very low acid strength of phenol, it cannot react with sodium bicarbonate, but it is react with sodium hydroxide. Actually, phenol dissolved in aqueous NaOH by forming water soluble sodium phenoxide and are precipitated or regenerated on acidification with HCl. As you have seen already in the reaction, that phenol dissolve in aqueous NaOH by forming water soluble sodium phenoxide and are precipitated or regenerated on acidification with HCl. Alcohols show no acidic character in aqueous solution. Thus, phenol do not react with neither NaCO3, but phenol react with NaOH. And as alcohols show no acidic character in aqueous solution, thus alcohols do not react with either aqueous sodium bicarbonate or aqueous NaOH. Always remember students, alcohols do not show acidic character in aqueous solution. Thus, alcohol do not react with either aqueous sodium bicarbonate or aqueous NaOH. Very weak acidic character of alcohols is revealed in the reaction with active metals. When alcohols are treated with very strong base like alkali metal sodium or potassium, they react to give sodium or potassium alkoxide with the liberation of hydrogen gas. As you have seen in the example, alcohol react with active metal sodium, it form sodium alkoxide with the liberation of hydrogen gas. Liberation of hydrogen gas is used to detect the presence of alcoholic OH group in the molecule. The next topic from this chapter is characteristic test for phenol. Phenols give one of the best tests, means when phenol react with neutral ferric chloride solution to give deep purple, violet or green coloration. Means either deep purple color, either deep violet color or either deep green coloration. And these colors are nothing but a color of ferric phenoxide. Ferric phenoxide. See here, phenol react with neutral ferric chloride and give deep color, means either deep purple, violet or green, and this compound is known as ferric phenoxide. So it is the characteristic test for phenol. Now the next topic is distinguished test for alcohol, and this test is nothing but known as Leuke's test. And what is Lucas reagent actually? Concentrated HCl plus zinc chloride, it gives Lucas reagent. So students, primary, secondary and tertiary alcohol can be distinguished from each other in the laboratory using Lucas reagent. See the reaction involved. ROH in presence of Lucas reagent give RCl, means alcohol change into alkyl chloride. So as I have already explained you, primary, secondary and tertiary alcohols can be distinguished from each other in the laboratory by using this Lucas reagent. An alcohol is changed into a alkyl chloride. Alcohols are soluble in Lucas reagent, but the product alkyl chloride is not soluble in Lucas reagent. Hence, the clear solution becomes turbid when product start forming. Tertiary alcohol react fast and the reagent turns turbid instantaneously. Secondary alcohols turn the reagent turbid slowly, and primary alcohols turns the reagent turbid only on heating. So we can distinguish the primary, secondary and tertiary alcohol by this method. Students, I hope you understand all this topic which I have covered today. We will continue another topic in the next lecture from the same chapter, alcohols, phenols and ethers. Thank you so much.